Okay, welcome to my fourth video, and now I'm going to show you an example of an impedance transfer with transformer. So this is a good example about impedance transfer, and I hope you will understand the use of it. Now, first we're gonna see what is the example, then we are gonna solve it. So it says that a speaker, I don't know if you see about the light, here it says a speaker of 9 ohm resistive impedance is connected to a supply of 10 volts with internal resistive impedance of 1 ohm, as shown in figure 1. By A, we need to determine the power absorbed by the speaker, and by B, to maximize the power transfer to the speaker, a transformer of 1 divided by 3 turns ratio is used between source and speaker, between the source and the speaker. Determine the power taken by the speaker. So now, in the first situation, we only have simple circuit without a transformer. We have a 10 volt alternating current supply with internal resistance of 1 ohm, and we connected to this circuit a 9 ohm resistor, 9 ohm speaker, and we have to calculate what is the power in this situation. So for A, there is no transformer. Let's just see what is the power. By Ohm's law, you know that I, or the second Kirchhoff's law, I is going to be equal to the supply voltage, 10 volts, divided by the series resistance of the internal resistance and the speaker. Now we will want to calculate the current in this circuit. And that is 1 ohm plus 10 ohm, and that is 10. So a current of 1 ampere is going in this circuit. Now we are going to calculate what is the power absorbed by the speaker, and that is equal, well, I squared times the resistance of the speaker and you get 1 squared, that is 1 times 9, and you get 9 watts of power. So this, the power of the speaker is now 9 ohms. So that's a little bit low. Now we will see what if we put a transformer between the source and the speaker with a turns ratio of 1 divided by 3. We have to calculate what is the power taken by the source. So this was 9 watts with 9 watts of power without the transformer. Now, if we put a transformer, also the supply voltage is the same, 10 volts, with internal resistance of 1 ohm. We put a transformer here. Here is the speaker now. Current will go like this. Now, in my this is we have here a turns ratio of 1 divided by 3. So in my previous video, I showed you what is the impedance transfer, where when we want the load on the secondary, transfer it to the primary with this same measurements. The input, the current and the 10 volt stays the same, but we want this output load on the primary side. Refer this to the primary side, and the formula for that was Z2 prime was equal to A squared times the impedance, output impedance. And then the equivalent circuit for this now the equivalent circuit for this will be here, like something like this: 10 volts, internal resistance of 1 ohm, and this is the transferred value of the speaker on the primary side in this particular situation. So now we transferred the 9 ohms to this side. Why? Because now we cannot calculate what is the voltage here. We don't have those parameters, so we are gonna transfer this on this side, and the formula for here for that is A squared times the actual impedance or the resistance of the speaker. So now let's calculate. So Z2 prime is equal to 1 divided by 3 all that squared times the resistance of the speaker, that is 9 ohms. So Z2 prime is equal to 1 divided by 9 times 9 ohms. This cancel each other out, and we have 1 ohm on the primary side. Now we so the transferred value or resistance of this speaker on the primary side, when we put the transformer with this turns ratio, is 1 ohm on the primary side. So now the current on this primary side, when we put the impedance on the secondary, is going to be 10 volts divided by the internal resistance times the impedance of this speaker, the transferred impedance of this speaker, that is 2 ohms. 1 plus 1, this is now 1 ohm. Then we have a current of 5 amperes that goes on the primary side here, sorry, on this equivalent circuit now. So what is the power of the speaker absorbed in this actual in this situation when we put here the transformer? Well, that is equal to I squared times the transferred impedance over here, and that is equal to 5 squared times 1, and that is 25 watts. Now, as you can see, before in this circuit, this consumed I think 9 watts of power, but when we put a transformer here, as you can see, the turn ratio is 1 divided by 3, then this voltage here rises here, and we maximize the power by putting the transformer. So in this situation and in this situation, the power here is the same, but because we don't have enough of we didn't use more measurements to determine what will be the current here and the voltage on these coils. We transferred this speaker on the primary side, and now the power on the speaker is 25 watts. So that's about almost 3 times more than when we didn't use transformer. So thank you for watching, and see you in my next video.